All right. So now we're doing freeCodeCamp, Legacy Python for everybody, the Tuples collection, right? He calls it tuples. I'm calling it tuples. I'm sure a lot of people call it tuples, in fact, but I'm still calling it tuples because that's the word I see when I see that. That's the word I see when I see that word. Hold on a second. Let's get out the notes. Let's type this down. Boom. All right, let's go all the way to here. Shorten this up a little bit. And let's start with a chappy 10. Right here. How about right here? Chapter 10. Tuples. He's going to say tuples so much, you're going to want to say tuples. I might even want to say tuples, but I'm going to try to say tuples every time he says tuples so that I can say tuples forever. Let's go.
Hello and welcome to Chapter 10. Now we're going to talk about our third kind of collection called tuples. But tuples are really a lot like lists. There's not too much to them.
All right, let's give it a second before he gets into talking about tuples. Look, we're all humans, okay? And we can program ourselves any way we want. And if I want to program myself to see this word and say this word as tuple, guess what? I'm doing it. Tuples are like lists. All right? Tuples are like lists. Okay? Tuples are another kind of sequence that function much like lists. Okay, keep everything plural because it's plural, right? They have elements which are indexed starting at 0. Okay, so it's just like a list in that regard, just like they said. Let's bring this down to and start here. Let's say x equals, I'm not calling it x, so friends equals, and now we're going to have a friends list inside of here. We're going to have Joey. Let's format it up before we go hard on labeling these. So we don't gotta, you know why. We don't want to do too much thinking. I don't. Let's do it. All right, so we got Joey. We got Chandler. And we got Ross. The friends. All right. Now we're going to print. Let's take this, the space with these, so we can easily have this on any line we want. All right, there we go. We're going to print friends at 2. All right, and that's going to give us 0, 1, 2. That's going to give us Ross. All right, Ross, boom. Then we're going to say age is equal. Then we're going to make another tuple. All right, and we're going to give it 1, 9, and 2. All right. And then we're going to print what? Oh, when we type it, I guess we're going to have these spaces, and then when it gets printed out, it prints out sans spaces. I guess that's what's going on here, and I like the look of it, so I'll keep doing it. And then it's going to print out. Oops, it's going to print out 1, 9, and 2. Okay, and then we're going to print the max. Did we go over max yet? Well, if we didn't, it's easy. Print the max of ages. It's just a function that goes through a list or a tuple or whatever, and it'll print out. If you say print, anyway, it's going to get the largest one. All right, so 9, boom, just like that. I don't know how. I don't know the actual code they used in Python because I'm not at that level by any stretch. But anyway, it doesn't matter. Let's do this. I'm going to save this time thusly. All right, so for enter in Y, iterable. For iterable in Y. I don't like that. For age in ages. Let's do that. That's a lot better. Ooh. For age in ages, what we're going to do here, let's not. Let's go to the end here and tab it over. We're going to do print age inside of here. All right. I don't know what the dots are for. Honestly, I don't know what these dots are for, but let's put them there anyway. Why not? All right. They look cool enough. And then we're going to say 1 because it's going to go through this iterable, right? It's going to go through what is this thing called? Tuple? The tuple that is called ages on ours. It's going to go through the ages tuple to the first one, and then it's going to print out the first one. It's going to go to the second one, read it and print it out. All right. It's going to go to the third one, print that one out. Boom. And then it's going to go to blank, enter your next command or whatever. All right. And so that's how that works. I mean, it goes through a list just like, it goes through a tuple just like we would go through a list if we had a list, you know, they're up in the notes somewhere. All right. So that's that. And that's what he's going to say. I bet.
They're really kind of reductionist version of lists. They're,
oh, what are you talking about?
Third kind of collection.
Let's just start from the beginning.
Welcome to Chapter 10. Now we're going to talk about our third kind of collection called tuples. But tuples are really a lot like lists.
Tuples.
There's not too much to them. They're really kind of reductionist version of lists. They're so they function very much like lists in that. You know, they have things, and the difference is there are no square braces. There is a parenthesis, round brace, or whatever. And they have positions 0, 1, and 2, just like a list. And you can look things up, x sub 2. So x sub 2 is actually the third element here. And so that prints out Joseph. You can assign, make a tuple here. This is the constant syntax for a tuple. And print that out, and the print statement shows you that this is a tuple, not a list, by showing you round parentheses. And a whole bunch of functions that work with lists work the same way with tuples. You can put a tuple at the end of an in statement into for, as you might expect, and then it iterates through the tuples. Tuples maintain order, so it prints out 1, 9, and 2. So,
of me saying tuples or tuples every time.
So literally, this bit of code here could be identical whether it was a list or a tuple. It really would do the exact same thing. The difference...
Bro, they're going to get me saying tuple. So the question is, why? Why? Where's that question? Why? Why have another data type that's exactly like a list? Except for you put it in... parentheses instead of, why? I don't get it. Anyway, so tuples, yeah, we're gonna have to call them tuples because this guy will not stop calling them that. I can't combat that. Like, this guy's been saying that probably since the 50s.
It was a list or a tuple. It really would do the exact same thing. The difference between tuples are that they are immutable. Once you create the tuple, you can only sort of assign a tuple, but you can't modify it. You can modify a list. So if we take a look at a list here, we make a list that's 987, and we...
All right, let's write this down before we go into this. I'm still thinking about how I got beat by this tuples gang. It's almost hurts my pride. But guess what? You live to see another day. All right. But tuples. I'm still going to call it that. But tuples are immutable. But tuples are what? Are immutable. Okay. We don't need all of that, but 1T. All right, let's come up here. Unlike a list. Oh, here's the difference. Unlike, unlike a list, once we create a tuple, we cannot alter its contents. Tense. There we go. Similar to a string. Boom. Okay. I guess there's a reason that we would want to do that. That's a lot of crap we got to type out. Let's type it out. All right. Values equals, let's say 987, 9 comma 8 comma 7. Okay. Then we're going to take this like thus, copy it, drop it. We'll say values at 2 now equals 6. And when we print values, print values, what we're going to get is 8. We're going to get this. Except for it's going to have the 6 instead of the 7. Because we changed 6. We changed 0, 1, 2 to 6. Lesson. Awesome. And there's that. So we've also got a slick move where we can say letters equal the string ABC. Okay. Whoops. And then we copy this, paste it here. All right. And we're going to say letters at 2 now equals D thusly, right? And so on this one, we're going to be getting the trace back, dot, 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 trace back, dot, dot, dot. Yeah. Because strings can't be changed. Strings are immutable. Okay, so there's that. And let's do one more. And we're going to do values 2 equals and then we'll say 5, 4, 3. Okay. And then we will say, oops. Then we will say values 2 now equals 0. Then we're going to get a trace back. Dot, dot, dot. And then we're going to say tuples. Tuples are immutable. Okay. And there we go. So let's listen to him talking about it. I said,
once you create the tuple, you can only sort of assign a tuple, but you can't modify it. You can modify a list. So if we take a look at a list here, we make a list that's 987, and we say x sub 2 equals 6. Well, that just means this 7 becomes a 6, and that's just natural, meaning we can reassign slots. We can delete things, we can insert things, we can mutate them, we can change them. So they're changeable, right? They're changeable.
Mutable.
But if we try to do that same thing with a string, So we say y equals ABC, and we know that this is position 0, 1, and 2, but if we try to say, let's change the C to a D by saying y sub 2 equals D, that is not allowed. And it says it doesn't support item assignment, and this little bracket, x sub 2 is what they call item assignment inside of Python. And so if we do the same thing then with a 3-element tuple, put that in Z, and we try to change this slot to be a 0, it's going to blow up because it's the exact same thing. And that has to do with the fact that once this assignment is made, this is not modifiable. Now, it turns out that the reason it's not modifiable is for efficiency. They take up less storage, they are quicker to access, and they're really designed internally behind the scenes in ways we don't really need to understand. They're just more efficient than lists. If all you want to do is store a list and look at it and then throw it away, you probably should use a tuple instead. So there's a lot of things that you can do with lists that you also can't do with tuples, but they're really just a corollary of this notion of non-mutability. And so, like, you can sort a list, but you can't sort tuples. You can add a 5 to the end of 3, 2, 1. Can't do that in a tuple, but you can in a list. And flip the order. ... So anything that you can do to a list that modifies the list, not allowed for tuples. And so you can take a look at the kinds of things that are...
Should we write this down? Things not to do with tuples. We need to write this down. All right, let's do that. Tuples, things not to do with tuples. What do we say instead of that? Tuples, that's not. Tuples, unavailable, mutating the, I guess that's what immutable. Mutating the, mutating a tuple is impossible. Mutating a tuple is impossible. So using sort, append, reverse, etc. will give tracebacks. That looks good. Period. All right, let's go.
So anything that you can do to a list that modifies the list, not allowed for tuples. And so you can take a look at the kinds of things that are inside the methods that are part of each list: append, count, extend, index, insert, pop. Many of these are modifying, and then count and index are the only ones that work for tuples. And so tuples are
okay. I see. Okay, let's do that. Let's write this down. Let's write this down. Let's type this down. What did it say? A tale of two tuples of two sequences? What do we say instead of that? Tale of two sequences. The list and tuple. What do we say? List and tuple method differences. List and tuple method differences. Right. Let's go down here and let's start with the first one. We're going to say example list equals list, the list constructor, right? And then if we do dir on this, oops, not there though. Whoops, not like that either. Let's do it like this. All right. If we do dir on this, What we're going to do is we're going to say we're going to have all these different methods that are available to us. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to do this 8 times. Copy it, drop it off. 1, 2, 3, 4, 5, 6, 7, 8 times. All right. And we've got append. And then we've got count, extend, index, okay, insert, pop, remove, reverse, and sort. Thing is, even though, all right, let's go to the next thing. And then we've got example tuple. Whoa, example tuple equals the tuple constructor. All right. And if we do the dir on that, dir, let me come over here. Not dir one, dir example list. Example list. Okay. And then we're going to do dir example tuple on this next one. All right. If we do this, it will print out only count in the other one. Let's grab count from here with the space. Drop it off twice. Back this one up, change count to whatever it says index right there. Index. So these are the only 2 things that are available, but that's not a problem. The thing is, it's not a problem because we could easily go through a for loop through any tuple. Like, let's say this was a tuple, right? Of all these. Like, let's say this isn't a list, but it's actually a tuple. We could just go through the tuple and put it in a list and then mutate that list just as easily as anything else, honestly. So it's not a big deal. So let's just go.
Limited lists. Now, at some point, there's going to be a but here to say, why do we like them? And the reason that we like them is that they're just more efficient.
Okay, they're more efficient. Let's write down exactly why and how they're more efficient. Tuples are more efficient. I'm going to keep going one way or the other. Tuples are efficient. Are efficient. We don't need a quantifier. Efficient. There we go. I gotta adjust this microphone cable. All right, so tuples are efficient. Why? How? Why? Since Python does not have to build tuple structures to be modifiable, okay. They are simpler and more efficient in terms of memory use and performance than lists. What? Since Python does not have to build tuple structures to be modifiable, they are simpler and more efficient in terms of memory use and performance than lists. All right, I guess since they don't have these many things in it, I guess. Well, I don't know what that means exactly. I don't think it's going to tell us or show us. So in our program, when we are making temporary variables, we prefer tuples over lists. Okay. Is that so? Is that so? Is that so? I'll take your word for it. I'm trying to think of some cases where that would be a thing, and I'm almost got a thing solidified in my mind, but not really.
You don't have to build Python in its own internal organization of these objects. And the reason that we like them is that they're just more efficient. They don't have to build Python in its own internal organization of these objects. It knows that they'll never be modified, because when you make a tuple, you as the programmer are saying, I'm never going to modify this, and Python won't let you do it.
Makes sense.
So it's higher performance, better memory use, and to a beginning programmer that doesn't really matter, but that's the reason. And so we tend to use tuples when in situations where we're going to make a temporary variable and then temporarily use it just a little bit and then throw it away without really messing with it. And we tend to use lists to build things up, et cetera, et cetera, et cetera.
I think I get what he's saying.
So
let's write this down before he gets wild with it. All right, what is this? Tuples and assignment. All right. So tuples and assignment. Whoa. There we go. We can also put a tuple on the left hand side of an assignment statement. Okay. What? Well, we'll see down there, huh? We can even omit the parenthesis. So what? I mean, what? Let's take this while we're here, and let's make this while we're here. All right. So we've got age. Age friend equals, and then we'll say 52, 54, Joey. All right, there we go. And then we've got this. We're going to say print friend. Okay. And then after that, it'll give us Fred. No, it'll give us Joey. All right. And then we're going to say AB equals 9998. Let's do this. We'll say value 1, value 2 equals 9998. Print A. You can say print A. Print value 1. And it will give us a 99. All right, it'll give us, because this, it's like destructuring assignment syntax over in JavaScript. This is this one, this is this one, and it knows it. And so that's as easy as pie. What did it say? We can also put a tuple on the left-hand side of an assignment statement. Yeah. Anyway, so I guess if we wanted to like make like 10 variables all at once, but then you can't change them. You can't change them, right? Or can you change them? If you do this, are they mutable? No, they can't be. All right, let's go.
The other thing that's interesting about tuples, and we've actually sort of seen this, is that you can put a tuple that includes variables on the left side of the assignment. And this takes a little getting used to, but it's really cool, and no other language that I know of does this. So if we say x comma y, that's a two-tuple. Both have to be variables. You can't put constants on this side. You know, it's like saying x equals 4, y equals Fred. right? So what happens is you can put a tuple on the far side of an assignment statement, and the 4 goes to X, and the Fred goes to Y. And you say, what's in Y? Well, Y is indeed Fred. And so this is like 2 assignment statements. Now, the way I've got this syntax, I would probably do, 2 separate statements, just not to show off that I know how to do tuples. And so here's another one, and they just move correspondingly. If you don't have 2 here and you do have 2 here, well, if you have 3 here or 2 here and 3 here and you don't match the number there, you get in some trouble. Now, if you just say...
The question I have is this mutable? Is the value mutable? Like if you change A later, like is this A the variable, or is this A a fixed thing? You know what I'm saying? And you know what? Since I don't think he's going to answer, we can always go ask the expert. Give me a second. I don't know if I'm crazy. Give me just a second. No, that's cool. All right, good. We're going to ask the expert. So if we assign some variables with tuples in Python like this, A comma B equals 4 comma 5. How about that? And then let's do the semicolon so it knows we're on. Is the A variable mutable? No. The variable itself is not, rather than it holds an immutable value, which is... So what I'm asking is if later we said something like A plus some A plus equals 1. No, excuse me. A plus equals 1. It won't make it 5. Okay. Yeah. All right, so what happens is that A plus equals 1 creates a new integer object with the value 5 and reassigns A to refer to this new value. Since integers are immutable, the original integer 4 hasn't changed. Rather, A now points to the new integer 5. Okay, so did the tuple A get deleted, or is it just some stuck data now? All right, when we did this, okay, so Python unpacked the tuple 4 and 5 and assigned the values 4 and 5 to A and B respectively. After that, the tuple itself isn't referenced anymore, so it becomes eligible for garbage collection, i.e. Python will eventually free up the memory used by the tuple. So Python will somehow get rid of it itself. When we later modify A using A plus equals 1, we're simply reassigning A, so it's just, okay. So it unpacks this and then throws it away some other way. Okay, cool. Let's go back to it.
X equals tuple, then that is the tuple in the list. But this is just a simple straight 99 value going into A. So you can put tuples as the left-hand side, and you can even do things like return a tuple from functions. That's a real nice Python feature that I like a lot. Tuples.
Okay, let's write this down. Okay, let's write this down. All right. So what we got here is tuples and dictionaries. Tuples and dictionaries. I may say tuples, I may not. I may say tuples. We'll see. So the items method in dictionaries return lists of key value tuples. Okay. Let's write down the example while we're here. All right, so we've got this one right here. We're going to say give me a second. I've got to rub my eyes because of all the translation work that I have to do to make this legible for people that aren't trying to be mysterious about their variable names. Okay. Oh, I hate having to do this. All right, so we've got these names in here. So we're gonna use friends again. So friends equals. It's not easy, guys. It's not easy having to translate from nerd into normie. It's not easy. These guys don't make it easy on me. So friends at Joey. Friends at Joey now equals 54. Okay. Friends at Ross we could have just taken that. Ross now equals 52. Okay. Let's do this. So for key, comma, value, in friends dot items, let's say friends ages. Let's take this and let's change them up. Since it's got the friend's name and the ages, we'll do friend's ages, right? Makes great. It makes sense, right? I like it. Let's do it. Friends ages dot items. All right. So for key and value in friends ages dot items, what? Let's do this. Nope, that's not what we're doing at all. Friends ages dot items. What we're going to do is have some dots. I'm going to take this while we're here because we're going to need it some more later. I'm going to have some dots here and do a print key value. Okay. And then we're going to have some more dots. Thinking. And then it's going to print out Joey 54. And it'll print out Ross 52. Okay. And then if we say tuples, what is this? What is it? Oh, let's say friends tuples now equals, what's D? Friends ages, friends ages dot items, right? Because that's what we're learning about. And then we're going to print friends ages, friends tuples, I should say. friend's tuple. Let's say tuple. This is whatever. It doesn't matter. All right. And then we're going to say down here, it'll print out, I guess it'll print out dictionary items. Did we make something? No, I guess it just prints that out. So dictionary items, and then we'll make a tuple. No, what? Is that a one tuple? Is that a one item tuple with the item as a list? Is that a list full of tuples? Is that what we're looking at right now? Is that what we got here? So we're going to have right here, the first one, we're going to have Joey. Let's put this down. We're going to have Joey in the first one, 52. Joey, comma 54, I should say. So we'll have Joey, comma 54. And the next one, we're going to have Ross, comma 52. Okay. And that's what's going to print out when we do that. Okay. Makes sense. Let's watch him talk about it.
Are also related to dictionaries, as we've seen in the previous chapter. So here we make a little dictionary. We make an empty dictionary by constructing an empty dictionary, stick it in D. So D is sort of like this place that can hold key value pairs. And we put CSEV, and there's a 2 in there, and Chen Wen, and there's a 4 in there. So we have this, associative mapping between C7 and 2 and Chen Wen and 4, all stuff we know. And now we say, hey, we're going to loop through the key value pairs here, and we've seen this syntax before, K comma V. So this is a tuple. So you can think of this as each one of these things is going to get assigned into this tuple, which means the key ends up in, and the first one's the key and the second one's value. I use the variable key KV all the time in code that I write, just for my own sanity. So KV are going to iterate successively through the successive keys and values in that. So this is going to run twice, and K is going to be CSEV 2 and Chen Wen 4. The order just happened to stay the same. And so if you say what is in one of these things, you can actually take D items, the items method within that dictionary, and say, hey, give that to me back, and then print tups. And it's a special kind of a class, but really ultimately it is a list of tuples. This is 2, this is the 0, and this is the 2, the 1, the first and the second. And then within each thing you get, you have a 2 tuple. And so, in a sense, this K and V are iterating through those things when we're putting D items here and D items there.
Yes.
One nice thing about tuples is that...
All right. Let's write this down. Hopefully it's the last thing we got to write, but maybe there's going to be something here. Wait, we can look. Tuples are comparable. Oh, no. This is the last thing we got to write. All right. So let's write it. Get pumped. Get pumped. The end of the video is near. Get pumped. All right. So we got tuples are comparable. All right. Tuples are Oh, let's make that R capital. Are comparable. Cinema bad. Comparable. Okay. Comparable. That's not comparable. There we go. All right. So let's go down here and let's say the comparison operators work with tuples and other sequences. All right, I forgot what those ones are. Oh, like the greater than less than. Okay. If the first item is equal, Python goes on to the next element, okay, and so on until it finds, let's drop this, until it finds elements that differ. Okay. What? The comparison operators work with tuples and other sequences. The first item is equal. If the first item is equal, Python goes on to the next and so on until it finds elements that differ. So this is greater because it starts with a 5 and this starts with a 0. This is greater because it starts with a 0, but the next one has a 3 and it's greater than 1. So this is bigger. Jones Sam is bigger than Jones Sally because L comes before M in the alphabet. So this is bigger than this right here. And then Jones Sally is bigger than Adams Sam because J is further along in the alphabet than A.
That they're comparable. They're comparable in the same way that strings are comparable, meaning
We didn't type that down. Let's type that down. Let's back it up. Let's type that down and we'll back it up. Oh. Learning. Yay. Let's take this because we're going to have to do it every other time. All right. So let's type this down. We're only going to do this. Okay. Let's do this. This and these first two are just numbers. So we've got 0, 1, 2. And this next one we've got 5, 1, 2. 5, 1, 2 area code. All right. So now we've got this next. Actually, let's take this. Let's take this whole thing. Forget about it. And drop it off. And 512 billion. 200. There we go. That's better. 034. 0. 3 4. 42. Doesn't matter. It's still less than that one. But since this is bigger than this, that's what counts. Not that this has 20 billion. What is that? 2 million and 1. You know what's going on. All right, so let's drop this thing off again, and let's change this 0 to Jones. And then let's get rid of this stuff, and oops, let's get rid of this stuff. Double this one up right here, and then do it 2 times here. 1, 2, boom. And we will have Jones Sally and Jones Sam. Jones, we should take him out. Copy that. And just drop this off Leslie. Jones Sally. And then we'll do Jones Sam over here. All right. Oh, yeah. Don't forget the fact that we've got true right here. We've got true. They're all true. True because they're all true statements. This one's also true. All right. And then we've got another one of these coming up. So let's slap that down right here. And let's change Sam Jones to Sam Adams. How about that? Adams. And yes, this is going to be bigger than this one, right? So that's how that works. Now let's watch him talk about it.
the nice thing about
Whoa. Crucial information was forgotten. True. Let's go.
tuples is that here and D items there. One nice thing about tuples is that they're comparable. They're comparable in the same way that strings are comparable, meaning that they're compared from left to right, with the leftmost or 0 tuple being the most significant. And it doesn't compare any further than it has to if it's asking less than. So if it's looking at, say, this first tuple, it starts at the left and says, okay, ask the question, tell me true or false. Is 0 less than 5? The answer is true. And so the answer to this overall expression is true, and it doesn't even compare those two numbers, those second and third number. They don't compare them. If, on the other hand, we're asking, is this less than that? It only looks at the first one and asks if it can answer the question. And the answer is, well, they're both 0. And so I can't answer the question, so I have to go to the second one, second pair, and 1 is less than 3, and so that means this is true. And it does not check this, even though 20 million is bigger than 4. It doesn't matter because these are the numbers that cause the true to happen. And the same is true if you do this with strings. Again, we start the first one. So Jones, Sally, well, that's the same, so we don't know the answer yet. And so Sally, Sam, well, okay, S, oh, they're the same. A, they're the same. O, L, and M. L is less than M, so, so the actual letter that makes the difference here is the L and the M, and leads to us being true. And so it goes left to right, but then even when it's doing strings, it's going left to right. That's just how string comparison works. And if we say is Jones, Sally greater than Adam, Sam, well, we check the first one and we check the J and the A. Well, J is greater than A, and so we don't have to look at anything else. We don't have to look at any more of these characters. We don't have to look at the second thing in the tuple. We have to look at that is enough to be true. So it only scans until it has a definitive answer. It doesn't scan any further.
True.
So now what we're going to do is use this comparable capability to sort these lists of tuples and then bring this all back and connect it more to dictionaries.
That would be cool. So let's do that. All right, so we got that looking great. Let's finish this part. What will the following code print? We've got D equals dictionary. So Quincy's going to go in there with 1. Bo's going to go in with 5. Chris is going to go in with 9 for key, comma I in dictionary.items. Look, write this stuff out. This is terrible. This is absolutely horrible. So just use letters instead of words. For K at I, K, comma I in D items, print K, comma I. So it's going to come out Quincy 1, Bo 5, Chris 9. Quincy 1, Bo 5, Chris 9. This one right here. Because we're printing out the K, which is the name, and then the I, which is whatever the number is. This guy loves himself, bro. Like he'll even put himself on top of these people. That is honestly, like where I grew up in the world that I grew up in, right? It is very proper to always put yourself last whenever, even if you're talking about your greatest enemy, you put yourself after him in the list. That's why in baseball and in football and everything, the home team is always on the bottom because that's just common courtesy. But this person, this has sold me. This person thinks he's better than this person and this person. This person grew up somewhere not cool. That's what I'm saying. That's what I'm saying. And you know what? It's not a big deal. Other people grow up in other places. But fact of the matter is, we are not the same. Me and this guy. And submit it. All right. So now we're on to, and I'm jealous. Yes, I'm jealous. Am I jealous? I'm jealous. I'm jealous. I'm jealous. I'll say it. I'm jealous. I'm jealous because I want to be a big timer. And for some reason, this nerd, this bald nerd, if you're bald, tough Nikes. This bald nerd, whatever. All right, so now we're on to comparing sorting tuples, and we'll see you next time.